Good morning, class 12th. In the subject mathematics today, we will continue integration by parts. Yesterday I explained how to apply this method. All the conditions of applicability of this method were explained to you with some solved examples. So today you need to have more practice on integration by parts. So I have taken here some examples, different types based on the same method how to apply integration by parts. So first question I have taken today as evaluate integration x square into e to the power x into dx. So I yesterday explained when you have product of two functions with direct integration of one of them is known, then we can always apply integration by parts. So x square into e to the power x has two functions. One is x square and another is e to the power x. So taking x as first function and e to the power x as second. Yesterday also I have explained how to take first and second function. And now applying the formula integration by parts, we have first function into integration of second, that is x square into integration of e to the power x is e to the power x minus sign of integration, again integration of second, that is e to the power x into differential of first 2x dx. And now first part is free from integration, that is x square into e to the power x. You will write as it is minus 2 taking outside integral x into e to the power x into dx. Again you have two functions, so you need to apply integration by parts, taking x as first function as e to the power x as second. So first function 2x into e to the power x minus sign of integration e to the power x into dx. When applied x into e to the power x by parts again. So after simplifying it is x square into e to the power x minus 2x e to the power x minus plus 2 e to the power x plus c, and that is your final answer. Now question number 2 is evaluate integration log x into dx. So sometimes you can have a single variable, single function only. So you can take that time log x can be written as 1 into log x. Now 1 is second function, as integration of 1 with respect to x is x. So log x will become second function. So you can write log x into x applying by parts minus sign of integration x into derivative of second function log x, that is 1 upon x into dx. So x will get cancelled. In the next step you will have x log x minus integration of 1 into dx, that is x log x minus x plus c, that is your answer. So this question was different, as sometimes you can have a single function, so you can write it reducible to two functions product taking 1 into that function. Then third example, evaluate 2x into e to the power x square into x square into dx. So sometimes first we need to apply, because here we have three functions 2x, e to the power x square and x square. So we need only two functions for integration by parts. So taking here substitution first, as you see the condition of substitution is first applied. So you will take x square equal to t, so that 2x dx is dt. So your integration becomes t into e to the power t into dt, and now you can apply by parts taking e to the power t second and t as first. So applying by parts, t into e to the power t minus integration e to the power t into 1 into dt, that is t into e to the power t minus e to the power t plus c. Putting the value of t, original variable, you will get x square e to the power x square minus x square plus c. Question number 4, evaluate e to the power x into cos x into dx. Make a note of this example, it is different type. When you will see that it is recurring during the process of integration by parts. So here you can take any one as first and second. I have taken e to the power x as first and cos x as second. So you will get e to the power x into sin x minus integration sin x into e to the power x dx, applying by parts as you know. Then e to the power x into sin x minus, again applying integration by parts on sin x into e to the power x, taking sin x as second function. So it is first function e to the power x minus integration of sin x, that is minus cos x minus cos x into e to the power x dx. Now further simplifying, it will become e to the power x sin x plus e to the power x cos x minus e to the power x cos x dx. So note here, you have got e to the power x into cos x again as same what it was given to you in the beginning, and you had called it let I. So it will become I, shifting I to left hand side. It will become 2I equal to e to the power x taking common sin x plus cos x, and I equal to e to the power x by 2 into sin x plus cos x plus c. Question number 5, evaluate tan inverse x into dx. So here you will take 1 as second function because it is only a single function, tan inverse x. So you can write it as 1 into tan inverse x, and applying by parts it is x tan inverse x taking 1 as second minus x into 1 upon 1 plus x square into dx. And now for this integral x upon 1 plus x square, you see substitution is applicable. So let 1 plus x square equal to t, 2x dx is dt, or x dx is half dt. So your question becomes x tan inverse x minus half dt upon t, that is log t, and putting the value of t you will get final answer x tan inverse x minus half log 1 plus x square plus c. And now question number 6, you have to evaluate yourself. Do these 4 questions yourself which I have written for you. Integrate sin inverse x into dx, integrate x to the power 4 into log x into dx. C part, integrate e to the power x into sin x into dx, and D part, integrate x square into sin x. These 4 parts of question 6 you have to do yourself. Make a note of it. Do question number 6 and show it to me.